In this video segment, I'm going to be talking about some of the aspects of the mathematical techniques that we'll be using in economics. And students come to this class with all kinds of experience with regard to math. And if you feel like you're very strong in math, some of this may or may not be as useful to you as those who need a little bit of a jump start, a little bit of a boost to try to add a bit of refresher material in terms of what we're going to be doing with the math in this course. Even if you're not as strong in math as what you think you'd like to be, I think this should be helpful to you in order to sort of at least define what the outer limit is of how much math experience you'll need in this course. I think you'll find that it's probably consists of the tools that you've seen before and have used in your prior math experiences. So let's talk a little bit about what we're going to be doing in economics. And this should be familiar to most of you, the Cartesian coordinate plane, where you've got 4 quadrants, 1, 2, 3, and 4. And anywhere within these quadrants, you've got some sort of ordered pair relationship of x and y. What that means is the x-axis, which is the horizontal, and the y-axis, which is the vertical. Any point on this can be drawn back to its intercept on these axes in order to define some point, whatever that particular point might be. And if it's in this first quadrant here, both values of x and y are going to be positive, and it's going to be positive y and negative x here, negative x, negative y. Now the good news is, for our purposes, we won't be working as comprehensively with all quadrants of the axis. Instead, we're going to be working the first quadrant almost exclusively. And so let's take a look at what we're doing in economics, and that is this. We tend to use the first quadrant only, and in econ it does seem like, for the most part, things of a dollar figure or a percentage amount are usually represented on the vertical axis, the y-axis, and things of a numerical or countable or measurable kind of quantity find themselves placed on the horizontal axis. And there's no rhyme or reason for it necessarily. It's just the tradition, it's just the custom. There's an argument to be made that these should be reversed, particularly if one is talking about the issue of dependency, but we'll get into that a bit more here. Let's talk about a case in point in which we have some point, some value here that we're going to say lines up with some x1, y1. Okay, and so we're going to call this point here the intercept on the vertical y1, the intercept on the horizontal x1. And we'll call that particular point, point A. Point A. And let's say something happens in which the observed value, whatever it is now changed, and now it's found itself at some x2, y2. In other words, now this is x2 and this is y2. Well, what's going on here is simply the fact that as the y value has grown in value, the x value has grown, the y value has fallen. And so as a result of this, we can make some interesting observations about what's going on. In particular, in this sort of two-dimensional place here, we could connect these 2 points, and as we know from algebra and from even math prior to that, any kind of a straight line takes the generic formula of y equals mx plus b. That's a generic formula right out of math textbooks that you've probably seen before, where some value of y corresponds to some unique value of x for any sets of observations that lie within that particular segment. The b value is where the line crosses the y-intercept, or the y-axis, if it does at all. If it doesn't, it's simply 0. But the more interesting value here is m, which most of you know is the slope of a linear function, or the slope of a straight line. We call the linear function is actually the equation. The graph of that is the straight line. So the functions then are graphable, and it's just one of the ways that we can express economic phenomena in a graphic sort of way. Because there are really 3 ways that we can talk about events, transactions, models in economics. I can simply describe them all verbally, or I can do them all with math, or I can do them with some sort of graphical representation, some sort of model. And in fact, we'll be using all 3, but primarily the first and third, a little bit less of the math, and that's why I really wanted to do this refresher, was to sort of talk about where the outer limit is. Okay? So y equals mx plus b. What about the slope? What is slope of a straight line? Well, it's basically the rise over the run, and that should be a familiar relationship to rise over run. And what it basically means is this. The rise is the change in this little Greek delta symbol, the change in the y value, that's the rise, the vertical, over the the change in the x. And in economics, and in fact in math and other disciplines, there's a lot of use of Greek symbols, and but rather than let that get in the way of the discussion, it's simply something to know about, and just be aware that we do see this from time to time. And all it really means is change. So the Greek delta symbol simply means change, and to even simplify this a little bit further, you could simply say it is new minus old. So it's y2 minus y1, y2 minus y1 over new minus old, x2 minus x1. And that's a pretty simple equation. And if we had values that we could plug in for this, then we could actually compute the value of slope. And since it is a straight line, the slope would be equivalent at every particular point along that. It's really one of the definitions. And so let's just sort of make up some values here and see what we end up with in terms of slope. And I'm just going to sort of make up some very simple values to plug into this formula here, y2 minus y1 over x2 minus x1. So let's do the math. y2 minus y1 is, in this case, is m equals 5 minus 8 over x2 minus x1, which is 9 minus 4. And we end up with a value of negative 3 over 5, or negative 3/5. And the negative sign is important, and it's going to be more important once we start talking about demand and supply, as well as a number of other relationships in economics. That as this changes, and I didn't label the second point, from A to B, we've got some sort of rate of change, and that's really what slope is rate of change. What about this negative value here? One thing that we can say about a negative slope is that it's downward sloping. And so if you consider the fact that it's, just think of it as like a hill, if it's going down, then you know that it's got a negative slope, and it's going to have a negative value. On the other hand, if it went like this, it would have a positive slope, and you could input any combinations of coordinates for these particular intercepts in order to do the math for yourself. And one thing in particular that I should also tell you is that oftentimes in navigating around economic models, students occasionally find themselves wondering, okay, is something increasing or decreasing, particularly if we're talking about the whole thing, the whole function moving, shifting, which I'll get into a lot more concretely in Chapter 3. And the big thing to know is this: orient yourself to the origin, because the origin is here down in the southeast corner. And so just think about this: if something's going up and or to the right, you know it's increasing. If it's going down and or to the left, you know it's decreasing. So keeping an eye on where the origin is should make it fairly straightforward, so that you'll know exactly where you're going at any one particular time. So anyway, I hope this is a helpful bit of a jump start and a refresher for those of you who are needing a little bit of extra attention in math. I would encourage you to read the Chapter 1 appendix. It's got some good information and should allow you to see more concretely how these functions work, including the fact that a lot of functions are curvy, in which case the slope of a curve is simply the slope of that line that is tangent to any one particular point on that. And if you do have questions, feel free to get with me individually, and I'll be happy to work.